So let us continue with the query languages in Oracle. In our last class, we talked about unary relational operations, which mainly focus on select from where, the major three operations. Let's take a look one more example of how we can add more conditions in the where part. So take a look of this query. Select the tuples for all employees who either work in department number 4 and make over 25,000 per year, or work in department number 5 and make more than 30,000. So you can see that these queries actually have like two parts of it. Either it's going to be department number 4 and make more than 25,000, and remember there's an OR operation over here, department number 5 and make over 30,000. So in this case, you can see that if we try to write the whole questions, the whole thing still is finding out the name of the employee. So we only select first name and last name from the employee table. So still working on just one table. The conditions now you can see is pretty long. It has two parts of it, either department number equals to 4 and salary greater than 25,000, or department number 5 and salary greater than 30,000. So you can see that if we try to work this code in the Oracle, it will simply try to find out anyone that satisfies these conditions. The important things I want to show in this slide is that you will be able to do whatever you want and add the parentheses using the word and or this kind of operations. We will be able to do a lot of different things. So if we try to continue the next part, you will see that we want to add more conditions on the where part. So for the rest part of the topics, you will see we try to extend the where part to have more and or those kind of operation. So that's what we discussed about the one table operations. Now it is time for us to see multiple tables, starting from 2. The first thing I want to introduce to you guys is actually a monster. This is what we call a Cartesian product. The idea is borrowed from the mathematics set theory. So what does Cartesian product do? This operation is used to combine tuples from two relations in a combinational fashion. So what it tries to say is that, saying that I have two tables. The first table is called R, the second table is called S, and the first table has several attributes. In this example, it has 1, 2 until n attributes. For the second table, it has go until m attributes. So if we try to Cartesian product the two tables together, the reason I'm saying it's a monster as follows. First of all, it will create one big table. The big table will end up with a table with all of the attributes from R and all of the attributes from S. So the number of attributes of this table will become n plus m. Therefore, it's a huge table by looking into the number of attributes. And that's not the end of it. The more interesting thing I want to talk is the next part. The number of tuples it will generate is actually gigantic. So what you can see over here is that the resulting relation has one tuple for each combination of tuple, one from R and one from S. So what that's trying to say is that it will end up with the number of tuples equals to the number of tuples in the first table multiply. This is the important thing for you to see. You will multiply the number of tuples in the first table with the number of tuples in the second table. So you actually end up with a gigantic table. Let's take a look at this example. You know that the department has 4 attributes with 3 tuples. What I'm trying to say is that if we look into this table, you see that the department table over here has 4 attributes. It has 3 departments. So the number of attributes is 4. The number of tuples in the department table is 3. Now, department locations has only 2 attributes with 5 tuples. So you can see that department locations has 2 attributes with 5 tuples. Therefore, if I'm trying to do a Cartesian product from department table cross product with the department locations, it will end up with a table with 6 attributes. So you can see that 4 attributes from department, 2 attributes from department locations, and the number of tuples in the new table that we're going to generate it would be 3 coming from the department multiply 5 from the department locations. So you can see that if we Cartesian product department with department locations, we will get a tuple with 4 plus 2 attributes and 3 multiplied 5 tuples. We end up with 15 tuples over there. It is a big result, big table that you will generate. So how can we do this? How can we do Cartesian product in Oracle? It sounds like it's a pretty interesting operation, and I want to show you how is that going to be done. And it's actually super easy. You already know select star, so we can find out everything, all the attributes that will be listed over there. And then all we need to do a Cartesian product is actually a comma. And you put this comma in the front part. So you say select star from department, comma, department locations. By simply doing so, you will end up with a Cartesian product of the 2 tables already. Let's take a look of it. So you can see that if we try to do this operation, select star from department and comma, department locations, as we said, you will end up with a big table with 6 attributes and 15 tuples. So if we put a semicolon over here, hit enter, you can see that first of all, there are 15 rows, which means there are 15 tuples being generated. And then the number of attributes is actually department name, department number, manager, social security number, manager, start date. Those are the 4 attributes coming from the department. Department number, department location, those are the 2 attributes coming from the department locations. So it's really end up with 6 attributes with 15 tuples. So now the question is, what is the data looks like? So if you try to look this one carefully, what you will be able to see is that it's starting from the research department. So you will have the research department and you will end up with 1 in Houston, administration department 1 Houston, headquarters 1 Houston. So what that really doing is actually having the research department append the very first row of the department locations in back of it. For the second department, it will append 1 Houston to the end of it. For the headquarters, you will also append 1 Houston to the end of it. So that's one first iteration. And now the second iteration is going to do the same thing. So you see that the research department and then append the second tuples from the department locations. Administration append second tuples from department location, headquarters doing the same thing. And then it's going to the 3 departments, go with the 3rd tuple with the department locations, 4th tuple, and 5th tuple. So what it's trying to do is that it create a huge table and put all kind of combination, all possible combinations, putting them together. So you will end up with a big table, okay? And that's what this can be done. If we try to, it is totally possible to Cartesian product more tables, more than 2. How do we do that? It's actually pretty straightforward. See that if I'm going to start select start from department, comma, department locations. Now let's have some fun. If we add employee here, put a semicolon. Now, try to picture this. The end table will have how many attributes? Let's think about this. Employee has 10 attributes, department has 4, department locations has 2. So the new table is obviously going to end up with 10 plus 4 plus 2 end up with 16 attributes. The more interesting thing would be how many tuples were generated. You may already guessed it. The number of tuples were generated will come from 8 from employee multiply 3 from the department and multiply 5 from the department locations. So let's hit enter and let's see what's going on. It will take a while to run through that. End up with 8 multiply 3 multiply 5 equals to 120. And that's what's happening if we try to do the Cartesian product. And feel free to try several of those things. So, if Cartesian product, like I said, if we Cartesian product employee with dependents, the result table will have how many attributes and how many tuples. That's also something that I want you guys to think about and try to play with it, have some tests, and basically you will get another Cartesian product, end up with 15 attributes as well as 56 tuples. So you may wonder, why are we doing that? Why are we creating some gigantic table and it doesn't seem like it makes sense out of it? Okay, and that's true because when we are trying to do the Cartesian product, it will generate all kinds of possibilities of the two tables or more tables that you try to Cartesian product together. However, you want to find something meaningful out of it. So how can we make things meaningful out of it? It needs the where operation to help us. For example, when we try to do the Cartesian product with the employee and dependent, so I want you guys to see. The employee has their social security numbers over here. Dependent also indicating which employee do they depend on. So you can easily see that the first employee Alice is depending on the employee with the social security number 333445555. You can find that over here, understand that is Franklin's kid. You do know how to use that as human. So when computers trying to finding out this kind of information, we need to provide that condition. So that you see you want to match the social security numbers over here with the employee social security number. That's why we are trying to do the operations over here. So we can try to do the Cartesian product select star from employee and dependent table where SSN equals to ESSN. So when we're trying to do that, and then we can copy and paste that operations over here, put a semicolon, and then hit enter, then you can see that we end up with only 7 tuples. First of all, we end up with only 7 tuples. And the one that survived the operation is the one that they have the social security number matches the ESSN over there. So you can see that this is the social security number of the original employee. This is the social security number from ESSN. And that is how we can find the matching with each other. And that is actually what we want to talk about in the join operation. So you can see that when we try to do a Cartesian product itself is usually not very meaningful. We try to make it make sense by adding a where condition. And that is what we want to see as the join operation that combines select from multiple tables and add a join operation condition to make sense out of it. In the next video, we will start talking with the join operation.